إذا الأمجاد قد عظمت فللأمجاد بانيها ومن يسعى إلى العليا سيدركها بما فيها ويبني مجده جذلا فروح الفذ يعليها ليصبح همة تروي عن العليا مغانيها.
Boys and girls, welcome to another exciting and explosive episode of the ITV Math Show. I'm your host and presenter, Mohammed Kota. Now, I think you guys, for those of you who have just joined our show, right, we've got an exciting lineup of a whole host of topics that we will be covering from grade 8 right up to grade 12 on a daily basis just here on ITV. Now, guys, those of you who have been introduced to us before, you guys have watched all our shows last year. You've utilized our systems. Hundreds of you have purchased our DVDs, utilized the set, and we've got the feedback from you. We saw the actual results and we saw the improvement in your results, right? Guys, today, remember, we are now shooting from grade 8 right up to grade 12 on different days. So we've got Monday right through to Thursday from 3:30 to 4:30 p.m. right here on channel 347. Okay, guys, today we're dealing with grade 10 and 11 exponents. Now, this is a topic. We're going to be going from exponents into surds, right? Now, this topic is being utilized or being taught currently in South Africa to all our grade 10s and grade 11s nationally in the country at the moment. We're starting with exponents, guys. Now, this topic, like we always say, has been introduced to you in grade 8 already. Now, the same laws that were taught to you in grade 8 are now just going to be utilized in grade 10 and 11, but just slightly at a higher level. So quickly, before we start with anything, like we always do in every show, guys, is that we start with the laws. So by now, I hope you have got your ITV math file in front of you. If you haven't started one, my advice to you right now is get a file or get an exam pad. Take down all the notes. Get your pens, get your examination pads ready, get your stationery ready. We know a lot of parents are watching the show, so everybody's all excited that what is this new dynamic show that is revolutionizing mathematics in the country at the moment. And this is the show, the ITV Math Show, right? Guys, remember, we've got viewers from all across the continent, and the feedback that we've got is phenomenal, right? We've been dispatching sets across the continent to prepare learners with mathematics because they are enjoying the style and they are loving the show. So I hope you guys sitting at home are enjoying the show just as much as we are enjoying it here in studio. Without any further delay, guys, let's get started. Put the heading, right? Lesson 1, parents. Put down today's date, right? Kids, learners, parents, teachers, put down the heading, exponents, and let's get started with grade 10 and 11 exponents. Okay, firstly, we've got to put down laws. Now, we cannot do exponents if we do not know the laws of exponents. Now, as we've explained, exponents deals, another word for exponent, which I've covered in the grade 8 show already, which I'm going to now have to redo slightly for grade 10 and 11. Another word for exponents is powers. Whenever we are dealing with powers. Another word is indices. Right? These are all synonyms. They all mean the same thing. Power, indice, exponent, and index. Right? Indice, the plural of the word index. So now we need to deal with laws. Now, the first law deals with multiplication of exponents. Right? The second law deals with division of exponents. The third law deals with raising a power to another power. Okay? I'm going to move over here to the side. Just going to put a line coming down. These are the examples on the side here. These are the worked examples. Don't worry about it right now. Don't take these examples down. Let's first go through the laws. Then we will take these laws and we'll apply it to the given examples. Remember, we're going to start you off from basic right up to advanced. Then we've got the base 0. Whenever the base is 0, the power 0. Whenever we have the power 0, and then we're going to be dealing with topic number 5 or law number 5, negative exponents or negative powers. How do we deal with negative powers? So that's our first law, second law, third law, fourth law, fifth law. Okay? For now, you can start taking down these laws. Right? You need to first pay attention. What I'm going to be doing right now is I'm going to be going through some basic examples with you just to start showing you how to manipulate these laws, how to play around with these laws, how to follow these laws religiously in order to get the solution, the correct solution that is required for you in the examination. So by now, I hope you've taken all these down. And let's start with the first law, guys. We're starting with the first law, the law of multiplication. So what happens when you're multiplying and bases are the same? Okay, so the rule is when you multiply and bases are the same, when you multiply and bases are the same, we add powers. That's your first law, guys, when we multiply and bases are the same. Now, just to explain to you what is meant by the word base. Now, I know many of you might be thinking, but why are you going so far back? Why are you now, Mr. K, why are you now going right back to explain to us what is a base? We know what is a base. You might know what is a base, but there are thousands and millions of learners across the country that still don't know what a base is. They don't know what a power is. They don't know what a coefficient is. And that's the purpose of the show, guys, to enlighten you, to teach you step by step, to analyze, to critically analyze and break up each component in mathematics so that we are able to give each term use the correct vocabulary, mathematical terminology in order to solve all our problems. Okay, so here goes. When bases are the same. So just to give you an example, if I told you minus 2x to the power 3, right? If I tell you minus 2x to the power 3, what is 3 known as? 3 is known as my power. So that's what we're going to be dealing with. That's the topic, guys. Exponents. We're dealing with powers. What happens to these powers when we multiply? X is known as my base. So my base is not x to the power 3. My base is just the x. So even if I had to add on y squared, y to the power 2, y is the base to the power 2. The base of the power 3 is x. And negative 2 is known in mathematics as our coefficient. Now, guys, don't write this underneath the law. This here is just to break up what a term looks like. That's a variable. It's a variable. It's an unknown. So we're looking at the term minus 2x3y squared or minus 2x cubed y squared, right? X is the base of power 3. Y is the base of power 2. Negative 2 is our coefficient. So once you understand that, now you understand what are bases and what are powers. Let's start with the first law, guys. We're starting with the first law where we are going to be multiplying. So when we multiply and bases are the same, same means identical. The bases must be the same. X and x, y and y. And the rule is multiplication. There's a reason I'm repeating this, because many of you get confused. You confuse the multiplication with addition. When you're adding exponents, when you're adding terms, many of you go and you start manipulating and playing around with the powers. You do nothing. When you are adding or subtracting, you do nothing with the powers. You leave it exactly the way it is. These rules are only applicable to multiplication, division, raising a power to a power, the power 0, and negative exponents. Has got absolutely nothing to do with addition and subtraction of terms, right? Of like terms. Okay, let's start with an example here. Let's start with an example. And the first example I'm going to do here underneath the law, just to explain to you. If I told you minus 2x to the power 3 times 5x to the power 5y. Okay? They tell you to simplify. The question tells you to simplify. You are multiplying. You are multiplying. You've got like bases. Your bases are the same, x and x. So what is the rule? When you multiply and bases are the same, you add the powers. So we are multiplying. So we start, like in English, like we start from left to right. We start with our coefficient. We start with the sign. Negative times a positive. And by now we all know that negative times a unlike sign, unlike positive and negative, or negative and positive, when multiplied or divided, gives us a negative result. And please make a note of that. For those of you who are doing this here for the first time, please understand this, that a negative times a positive or a positive times a negative gives us a negative result. So unlike signs give us a negative result. So then you might ask, so what happens to like signs? Like positive and a positive will always give us a positive. Positive times a positive will give me a positive, and a negative times a negative or divided by a negative will always give me a positive, right? So like signs when multiplied or divided will always give us a positive result. Unlike signs when multiplied or divided will always give us a negative result. So just to do this one here before we cut for an ad break, right? We've got negative times a positive, which is negative. 2 times 5 is 10. X to the power 3 times x to the power 5. We add the powers. 3 plus 5 is 8. Don't forget there's a y that's multiplied and we attach the y. And guys, that is our final answer, and that would be the answer to the first law. Okay guys, we're cutting for an ad break. I hope you've taken all these laws down. I'll see you guys in 3 minutes time. Boys and girls, welcome back to the ITV Math Show. We left you here before the break, guys. We're doing, for those of you who have just joined us, we're doing exponents. We're dealing with exponents grade 10 and 11. Whether you're in grade 8 or 9, you can still follow these concepts because they will be asked very similar at a very basic level. This is a basic example, guys. This year, even a grade 8, it's into this example here that we've done. The first example has been introduced to you at grade 8 level already. So if you are in grade 8 and you've started with exponents, you'd be able to associate with this because you have started it in school already. It's according to the year planner, the national year planner, exponents being the opening topic for most of the schools and for most of the provinces. Okay, so we started with the first law here. We're multiplying and bases are the same. We add the powers. I gave you example number 1. Contrary to what we usually do at the show, where we give you examples during the break, remember we didn't give you any examples to do during our first ad break. So let's go on to our second example. And the second example that we're starting up with here, we're just making it up as we go along. I tell you, negative 5a3b4 multiplied by 3a4b5. Okay, let's begin with this. That's another example, just to get you working with it before we actually attack the big grade 11, grade 10 and 11 style questions that we've put here. Remember, obviously, these examples that I've put here are not all the examples. They are good variety of the type of examples that you could see in your exam. And once you can do them and get them right and practice on it consistently, obviously, you know that you've mastered the topic and you know you're on your road to getting your distinction. And that's the purpose of the show. We want to see you get that distinction at the end of the year. So these are the 6 examples here, right, that we've chosen. We are obviously, like I said, these are not all, but we are in our next show, we're going to be doing even more complicated. We're going to actually even go into surds. So this is just the opening section or the opening show for exponents. Let's start with this one here. While I was doing a little bit of chit chat, I think many of you have started working on this problem already, and now you're waiting for the result. So let's see. Right, what did I say? You start with your signs first. Now we know if there's no sign in front, we can assume that it is a positive. So a negative times, remember we're multiplying. A negative times a positive is a negative. 5 times 3 is 15. A 3 times a 4 is 8 to the power 7. Remember, we add the powers. 3 plus 4. Remember the rule? Add the powers. And you can only do that when you're multiplying or dividing. B to the power 4 plus 5 is 9. Excuse me. There we go. That's your final answer. Is there anything further you can do with that? With negative 15, A7, B9? Absolutely nothing that you can do. So is that your final answer? Yes, that's your final answer. Okay, guys? Right. Now remember, the examples that we're choosing here in the show is completely different to the examples that we have inserted in our DVD pack. Right? The grade 11 and 12, the grade 10 pack, the grade 11 and 12 pack. And remember, if you haven't ordered your pack, if you haven't ordered the ITV math pack, you better do so now. You guys know the number that's appearing on your screen, 081-706-3986 is the number to call. As you can also email us at kwaymath@gmail.com to order the set. You guys have watched the advert on TV. You are watching the show. You want to have this whole complete pack from grade 10 right up to grade 12. You want to have these 12 DVDs with the workbook in the comfort of your home to be able to work with it. So you'll be using the notes that you are taking down. You'll be using the DVDs as well as the notes that you are getting from school. Putting it all together. Remember, you are taking charge of your own mathematics education, and that's the purpose of the show. Right. That was the first one, the first law of multiplication. We're now going on to the law of division. Let's see. Let's choose an example for division. Now remember, when we have a fraction, so if I told you minus 6x4 y6 over 2xy squared, what would this equal to? Now remember, this is division. Why is it division? Because it's a fraction. When we have a fraction, that line, that is a division in a fraction. Numerator, denominator. Remember, the line there represents division. Don't ever forget that. That represents division. And what is the law of division? When we divide and bases are the same. So let's put it here. When we divide and bases are the same, what's the law? What do? We subtract powers. Okay, so when we multiply and bases are the same, we add powers. When we divide and bases are the same, we subtract powers. So let's start here, guys. Let's do this example here. I'm just moving over here to the side. Like we always do, we start with our signs first. And write your signs one below the other, so it makes it so much easier for you to work out. And remember, write big, write it clearly and legibly so that you don't, remember, mathematics leaves no room for errors. You got to be accurate, you got to be systematic. And that's what we're here to show you, guys. We're here to show you systematic, best practice methodologies in mathematics. So let's start. Negative divided by a positive is a negative. Remember, what did I say? Unlike signs give us a negative result. Like signs give us a positive result. Remember, we're teaching you this step by step, assuming that you know nothing about mathematics. 6 divided by 2 is 3. x4 divided by x1 is x to the power. We're dividing and bases are the same. What do I do to the powers? According to the rule, I subtract. So 4 minus 1 is 3. Y to the power, 6 minus 2 is 4. And can we do anything with that? No, that is our final answer, right? And we just leave the answer exactly like it is. There's absolutely nothing. We must just make sure that in exponents, we don't have negative powers as a result. Your answer must always be with positive powers, right? You can make a note of that. Make a note of that here on the side, right? Make a note that your answer must be with positive exponents. While you are doing your calculation, yes, you can have a negative exponent, as you're going to see a little later, right? But in your final answer, let's put it down here, the final answer must be with positive powers. Then you know that you are right, okay? Let's do another example. I hope you've taken this one down. Let's choose another example. Let's make one up. Like I said, we're making up these examples as we go along. If I told you minus 3a2b5c over 12ab squared over 12ab squared. Right. We are dividing. What will the question in the exam say? The question will just say simplify. That's it. Simplify without the use of a calculator. Just simplify. Right? You know, you've got to show it step by step what you are doing. Right? Let's start here. Negative divided by a positive is a negative. right? Negative divided by a positive is a negative. Now watch, be careful here. Many of you make a mistake here. 3 goes into 3. We're now going to simplify 3 and 12. So 3 goes into 3 once. 3 goes into 12 4 times. So it's 1 over 4. 1 over 4. It's not 4. 3 over 12. Just to show it to you here. 3 over 12 is not equal to 4. 3 over 12 is equal to 3 into 3 once, 3 into 12 4 times. It's 1 over 4. 1 over 4. And that's how we get the 1 over 4. And that's a very common mistake. Many of you in the exams, you see a 3, you see a 12, you automatically, your mind tells you, because I have a 3, because I have a 12, because I'm dividing, the answer must be 4. Yes, 12 over 3. Meaning, if I had it 12 over 3, yes, that is equal to 4. 12 divided by 3 is 4. But 3 divided by 12 is 1 over 4. 3 goes into 3 once, 3 goes into 12 4 times. So that was just to show you what we are doing. How to simplify fractions. I know you're still asking the question, why are you showing us how to simplify a question at this stage in our life? Trust me, the millions and millions of you out there still at grade 10 and 11 level still don't know how to simplify a grade 5 concept of simplifying a fraction. Okay, it's the reality, it's the truth. I'm not going to lie to you and say, yes, you all know it. Right, so now we've got a2 divided by a1. Watch that. A squared divided by a to the power 1. We're dividing and bases are the same. We subtract the powers. Now, many of you now get confused. Where do I write the a? Do I put it on the top or do I put it at the bottom? Very simple. Look where the power is bigger. Where is the power bigger? The power is bigger in the numerator. So I put a in the numerator. If the power was bigger in the denominator, I'd put the power in the denominator. But the power is bigger in the numerator. So 2 minus 1 is 1. You don't need to put the 1 in. We know if you have an unknown like a, we automatically know the power is 1. If I have an unknown x, we know the coefficient is 1 and the power is 1. But I'm writing it down so that you understand what we did. We said 2 minus 1 to give me 1. B. Where is b bigger? B to the power 5, b to the power 2. Where is b bigger, on the top or at the bottom? Let's not talk about numerator and denominator. Let's talk top and bottom. Where is b bigger? Is it bigger on the top or is it bigger at the bottom? It's bigger on the top. So now we put b on the top. Right. 5 minus 2 is 3. And do I have a c at the bottom? No, I don't. So I'm left with a c. Don't forget to include the c. And that is your final answer. You don't need to put in the 1. Your answer is, neither did you need to put the 1 here in the front, because minus ab cubed c over 4 is the same as minus 1. So this is the same as writing. I'm just showing you. You don't need to write it like this. Minus ab3c over 4. It's exactly the same as saying minus 1, because there's an imaginary 1 before the unknown. Okay, so that and that is exactly the same. So many of you ask, if I put this as my answer, would I get it right? Yes, you would get it right. If I left it here, would I get it right? Yes, you would get it right. You wouldn't lose a mark. You might also ask, if I did put in the 1 here on the top, would I lose a mark in the exam? No, you wouldn't. But it's just natural, it's mathematically natural not to put the power 1 in the front, or not to put the coefficient, because we assume, because we're dealing with variables and unknowns, we already assume that the power there is 1. Okay, so that is our rule on division. Okay, so just a quick recap, guys. When we multiply and bases are the same, we add the powers. When we divide and bases are the same, we subtract the powers. We're now going on to raising a power to another power, guys. Right? So, in fact, let's go for break. Let's go for break. We're now going to be cutting for an ad break. Put the power, raising a power. I'm erasing all of this. And we're starting with our next law, which is law number 3. Law number 3, where we are raising a power to another power. And this is a very, very important component. So please stay tuned, right? You guys getting a 3-minute ad break now? Take a bit of a breather, recap, refresh on all the notes that we've done, and I'll see you guys in 3 minutes time. Boys and girls, welcome back to the ITV Maths Show with me, your host and presenter, Mohammed Kota. Hope you guys enjoyed. I hope you've refreshed and consolidated your notes during the ad break. Went through whatever we've done in the first two segments. We're dealing with, for those of you who have just joined us, we're dealing with exponents. In fact, we're saying that it's for grade 8, for grade 10 and 11. But remember something, that grade 8s right up to grade 12 can be using, will be using the system. So if you're in grade 8, grade 9, 10, 11 or 12, this show is definitely for you. Okay guys, we're starting now. We ended off with division. We did let's quickly recap. When you multiply and bases are the same, you add the powers. When you divide and bases are the same, you subtract the powers. When you raise a power to a power, now we're doing raising a power to a power. So when you raise a power to another power, you multiply powers. Let me give you an example of this before we actually get started. Right? Example. If I told you, x to the power 3 to the power 4. This is equal to x to the power. We're raising a power to another power. So we multiply the powers. 3 times 4 is 12. There we go. Right? 3 times 4. It's not 3 plus 4 to give me 7. It's 3 times 4 to give me 12. Let's do another example here, guys. If I told you x3 y squared to the power 3. This is equal to x to the power. Remember, we're removing. Why are we multiplying the powers out? In order to remove the brackets. We want to take away the brackets. We don't want brackets in our final answer. Okay, so it's 3 times 3 is 9. Y to the power 2 times 3 is 6. So we got x9, y6 without the brackets, and we've removed it. Remember, the question says simplify. So they give it to you in a complex situation, and you got to use your rules of exponents in order to bring it to its most simplest form. Okay, let's look at another example, guys. I'm taking you up in levels of difficulty here. If I told you minus 2x cubed into x squared, right, to the power 3. Be careful now. We do the brackets first. So leave the minus 2x cubed outside the brackets. Times x to the power 2 times 3 is 6. Now we are multiplying, guys. Now we are multiplying. We're multiplying and bases are the same. We add the powers. We go back to our first law of exponents. So it's minus 2x to the power 3 plus 6, which is 9. And there we go. That is our final answer, minus 2x to the power 9. Let's do one more example, guys. We do one more example. If I told you 4x3 y5 to the power 2. Right. Now, I said, when you raise a power to a power, you multiply the powers. But remember, it's 4 squared. It's not 4 times 2. It's 4 squared. So 4 squared is 16. X to the power 3 times 2 is 6. Y to the power 5 times 2 is 10. Many of you in the exams, guys, you make a mistake and you say 4 times 2 is 8. You give the answer as 8x 6 y 10. That's incorrect. That is wrong, guys. That is completely incorrect. You cannot say 4 times 2. It's 4 squared. 4 squared is 4 times 4. 4 times 4 is 16. X to the power 3 times 2 is 6. You only multiply the powers, not the coefficient. Y to the power 5 times 2, y to the power 10. Something also that I'd like to just enlighten you about, right? Remember, we're taking down these examples. I'm showing you how to manipulate it. I want you to remember something. If I have a negative base, so let's say minus 2x3 to the power 3, or let's make it to the power 6, right? A negative base to an even power. Can you see the number 6? The number 6 is an even number. The number 6 is an even number. So a negative base to an even power is always positive. But a negative base to an odd power, right? What are your even numbers? 2, 4, 6, 8, 10. What are your odd numbers? 1, 3, 5, 7, 9, 11. Your odd numbers. So a negative base to even power is positive. A negative base to an odd power is always negative, right? Remember this rule. It's going to assist you, just to show you where it's going to be used. right? Remember, I'm showing you systems. I'm showing you examples. If I take the number minus 1 to the power 99, come on. Are you going to say minus 1 times minus 1 times minus 1 times minus 1 times minus 1 99 times? That's going to be impossible. In fact, it's not impossible. It's just going to be absurd. It's going to be crazy, ridiculous, right? So negative to an odd power, negative to an odd power. The number 99 is odd. The number 99 is odd. So a negative base to an odd power is negative. So your answer is minus. And you know, 1 times itself, 99 times is still 1. Right? 1 times 1 times 1 times 1 times 1 times 1 times 1, 99 times is not 99. It's 1. Right. If I told you negative 1 to the power 100, now the number 100 is an even number. So negative to an even power is positive. And 1 to the power 100 is 1. And that is the difference, guys. That is why I showed you that rule, that a negative base to an even power is positive. A negative base to an odd power is always negative. These are little tricks of the trade. These are things that you need to remember when dealing with algebra, when dealing with exponents. If you do not know these concepts, if you do not remember these concepts, you will never ever be able to get the correct answer in your exam. You'll be losing marks, but not knowing exactly where you lost and how you lost the marks. Okay, so we've done the power, we've done raising a power to a power, and raising a power to a power, we multiplied powers. Let's go to our next law, the power 0. So any base, let's write the rule down, any base to the power 0 is equal to 1. Example, what do I mean by that? If I tell you x to the power 0, any base to the power 0 is 1. Let's pick up the pace. If I told you x to the power 0, y squared. So x to the 0 is 1 times, there's a multiplication. If there's no sign, it means multiplied, y squared. And 1 times y squared, we all know, is y squared. Any number times 1 is still the same. Right, let's look at another example. If I told you 10x squared y over 5x to the power 0. Now, 10 divided by 5 is 2, right? We can use the division law that when we're dividing and bases are the same, we subtract the powers, right? 2 minus 0 is still 2. Or we can leave it as 10 over 5 is 2, x squared y over, we sorted 10 divided by 5, we've already got the 2. Now we know x to the power 0 is 1. Any number upon 1 is still itself, so we're left with 2x squared y. And there we go, that is your final answer. Okay, let me show you. Let's do more. These are all the types that you could see. This is how the power 0 can be manipulated in different scenarios. Remember, you need to do, then the purpose of the show, the purpose of our DVDs, and the purpose of all this resource material that we are piling you with. Remember, you are rewriting your own study guide at home. For many of you who did not purchase the DVD, you are rewriting your own study guide here at home. And what you're going to be taking an entire year, because systematically, show for show, we're going to be doing a certain concept. But if you want everything combined at one sitting, get our DVD set, guys. Get the grade 10, 11 and 12. You guys know the number to order, 081-706-3986, or you can order via kwaymath@gmail.com. Right, get on the phones and start ordering. Okay, let's go through another system here, guys. Let's go through another system. Now, let's see, how else can it be phrased? What if I told you minus 3x into 2x squared y cubed to the power 0? Now there's the power 0. We're dealing with the power 0. Now any base to the power 0 is 1. So we're left with negative 3x times this entire system here is any base to the power 0 is equal to 1. So it's times 1. So minus 3x times 1 is minus 3x. Okay, that's negative 3x. You cannot say that this entire problem is equal to 1. Because remember, the power only belongs to the base, not to the coefficient, or not to the term that is attached to the base. Okay, so please make sure you're understanding this and how to manipulate and how to process this kind of a scenario. Let's give you one more. let's give you one more example here. Let's do one more example. If I told you minus 2x to the power 0 into 3x3y squared. Right, be careful now. X to the power 0 is 1. So it's minus 2 times 1 times, that's 1, there's it, minus 2 times 1 times 3 squared is 9. X to the power 3 times 2 is 6. Y to the power 1, there's a 1 there. 1 times 2 is 2. Now, minus 2 times 1 is still minus 2 into 9, x to the power 6, y squared. Negative times a positive is a negative. 2 times 9 is 18, x to the power 6, y to the power 2. And there we go, guys. That is our final solution. And that's how we deal with the power 0 in an expression. Okay, guys? I hope you are taking all this down. I hope you are taking all this down, right? We're cutting for an ad break. What I'd like you to do, I'm giving you a little task. You've got 3 minutes now. I want you to try and redo all these 5 examples, 5 or 6 examples that we've done in this segment, and make sure that you understand it carefully before I go on to negative exponents, and then we'll be starting with these 6 questions. Obviously, we might not finish all of this, but we will then continue with this in our next grade 10 or 11 slot. Guys, start working in your break. Guys, welcome back to the ITV Math Show. I'm your host and presenter, Mohammed Kota. We're shooting here from our studios here in Johannesburg. We are here to show the world that here we are making a difference in this country. We are making a difference in mathematics, and we'd like everybody, the purpose of the show is for everyone in the country to be actively involved. So you cannot be sitting on your couch, eating your popcorn, drinking coffee, watching the show, and just enjoying the entertainment that's going on. This is not entertainment. This is work. You need to be involved. Get out your pens, get out your books, get out your scientific calculators, start paying attention, and let's start getting this right in typical teacher style. Right? Okay, let's get started. We're now going to be dealing now with, we've dealt with the power 0. Just to recap, for those of you who have just joined us, we've started with exponents for grade, basically 8 to 12, right? Although it is a grade 10 and 11 show, we started with the laws. We're going through the laws. We did multiplication. When you multiply, you add powers. When you divide, we subtract powers. If you miss the laws, if you've missed the segment, you need to go up onto the internet, go on to itvnetworks.tv. Within a couple of days, the show will be uploaded. You can then download the show and you can watch whatever you've missed. So we said, when you multiply, you add the powers. When you divide, you subtract the powers. When you raise a power to a power, yes, you are right, you multiply the powers. Any base to the power 0 is always equal to 1. And I've given you a host of examples under each of them. Right, let's now go on to negative powers. How do I deal with negative powers? Now, this is very crucial. It can become a little tricky. So you need to pay attention. What happens when we have a negative power? Now listen, and you need to know what I would suggest for those of you who don't know how to deal with, so this is law number 5, right? Law number 5, how do we deal with negative powers? How to deal with negative powers. Let me give you an example of what this looks like. Right, if I told you 5x to the power negative 2, right? Say you came to a situation just before your final answer, or in fact your final answer, you ended up with 5x to the negative 2. What did we say? We said that your final answer must be with positive exponents. It's got to be with positive powers. So we've got 5x to the power minus 2. Right, what happens here? What happens in this situation? How do we get it to a positive power? And that's what this law deals with, the negative power. You can see the negative power. We need to convert it to a positive power without changing the answer, right? We need just to rewrite that negative with a positive solution so that in our answer will always be with positive powers. How do we do that? Many of you still don't know how to do it. Watch. This is 5 times x to the minus 2. So watch this. We take the 5, we put it down. That's 5. X to the power minus 2. We bring it down to the denominator. So we make a fraction. X to the minus 2 comes down to the denominator in your next step. as x to the power plus 2. And there we go, that's your final solution. That's how you bring a negative power. So, when you're bringing, you cannot just bring the power down. Remember, the power does not exist on its own. The power is attached to the base. They are super glued. They are super glued. They can never be separated. A power and the base are married. They married in court, right? They are joined at the hip. They are a pair of Siamese twins. They can never ever be separated. A power and a base move together, right? They always move together. Where the one goes, the other one has to go with it. So if the base moves, the power moves with it. But the power cannot never move on its own. Power never moves on its own. It's the base that moves. The power follows. Okay, so x to the minus 2 comes down to the bottom. The sign of your power changes. The sign of your power changes. Right? So it doesn't, many of you, when you bring x to the minus 2 down, you make it negative x to the plus 2. No, not the sign of your base. The sign of your power changes. So here's another example. If I told you 2a to the power 2, b to the power minus 5, over c to the power minus 4. What would this be? Now we need to sort this out. We need the powers to be positive. How do we do that? We've got a 2. A squared is positive, so it remains. B to the minus 5 comes down as b to the power plus 5. C to the minus 4 comes up to the top as c to the power plus 4. And it's multiplied. And it's multiplied. Remember, when you're bringing it up, it's multiplied by whatever is on the top. So it's times c to the power plus 4. And that's how you would sort it out. So 2a squared b to the minus 5 over c to the power minus 4 will be written in your final step as 2a squared c to the power plus 4 b to the power plus 5. Okay, that's another example. Let's go through another 1 or 2 examples before we actually get started with the exam type questions. Right? Again, like I said, the sign of your power changes. If I had 10x squared y3 over 2x5y. Now be careful. Watch what happens. Right? Let's make it interesting and let's make that a negative. How do we sort this out? As it stands, there's no negative powers. As it stands, there are no negative powers, but we need to simplify. Watch what happens. Negative divided by a positive is a negative. 10 divided by 2 is 5. X to the power 2 over x to the 5 is x to the power 2 minus 5. Remember, when we're dividing, we subtract the powers. So 2 minus 5. Y to the power 3 minus 1. This is equal to negative 5 x to the power 2 minus 5 is not 3. 2 plus 2 minus 5 is negative 3. Remember, we're now dealing with our integers. Y to the power 3 minus 1 is 2. So, can that be my final answer? Yes, I'm right until here. That's correct. That's correct. But can that be, if the question was for 3 marks, will I get my full 3 marks? No. How many marks will I get there? Only 2. Why? Because I did not rewrite it with positive exponents. Again, I'm stressing that every time you're dealing with exponents, your final answer must be with positive powers. Right? This is equal to minus 5 y squared. X to the plus 3 comes down. X to the minus 3 comes down to my denominator here as x to the power plus 3. And there we go. That is my final answer. My final answer is minus 5y squared over x to the power 3. Okay? Guys, I hope you are following this. I hope you are processing this kind of information. This is a lesson taught, and you cannot be sitting on your couch just watching the show. Guys, you guys got to be actively involved. You got to be participating. You guys got to be listening, opening up your minds. Remember, mathematics opens up your minds and makes you see all these steps, step by step. Okay, now what we're going to do, we're wrapping up, we're coming towards the end of the show. Okay, but I'm going to give you guys, we're going to do things a little different. I'm going to give you these 6 to do as homework. Okay, listen carefully. Till our next show, right? So you got to watch. You got to make sure. Remember, we are airing every day from 3:30 p.m. to 4:30 p.m. CAT, Central Africa Time. What channel? Channel 347. What's the channel name? ITV, right? You can also go on to itvnetworks.tv. Check all our schedule of shows. You can also email us at kwaymath. You'll see the email address appearing on your screen now and again as a flasher, right? kwaymath, kwaymath, kwaymath@gmail.com, or you can contact us to order the DVDs at 081-706-3986. These are the questions I'd like you to take down. We're coming towards the end of the show. The first question, 4 into, right? You better take it down quickly, or for those of you who got PVR, press pause. 4 into -2, x to the power 3, y squared to the power 3. That's the first question. The second one, 2 to the power 3, all squared times 2 to the power 4. That's times. The next question, 3x squared y times 4x4 y to the power 3 over 6x6 y6. The next question, question number 4, -12a cubed over 15 m to the power -2, all squared. Number 5, 8y4 over 4y6, all to the power -2. And the last one, x plus y. If you are in grade 10 and 11, you've already seen this already in school, right? So until the next time, here's this x plus y over x to the power -1 plus y to the power -1. Each of these questions are worth 3, 4, 5 marks in the exam. Make sure that you take our laws that you learned in today's lesson, apply it to these given situations, and we'll calculate the memo for you in our next show. Guys, I hope you guys enjoyed our show, this exciting, dynamic show called the ITV Math Show. From me, your host and presenter, Mohammed Kota, I say, Assalamu alaikum wa rahmatullahi wa barakatuh.
الأمجاد قد عظمت فللأمجاد بانيها ومن يسعى إلى العليا سيدركها بما فيها ويبني مجده جذلا فروح الفذ يعليها ليصبح همة تروي عن العليا